NuScale is taking part in the nuclear power renaissance with its small modular reactor SMR technology designed to deliver safe, scalable, cost-effective, and reliable carbon-free power. The company's core technology, the NuScale Power Module (NPM), generates 77 MWe of electricity and leverages well-established nuclear principles, integrating components, simplifying systems, and utilizing passive safety features. This design enables the construction of power plants near electricity or process heat demand sites. With over $1.8 billion invested in development since 2007, NuScale has secured 478 patents globally, with 194 additional patent applications pending. The company made history in September 2020 by becoming the first SMR to receive a Standard Design Approval (SDA) from the U.S. Nuclear Regulatory Commission (NRC). The NRC's final rulemaking approving NuScale's design certification took effect in February 2023, allowing customers to move forward with plans to develop NuScale SMR-based power plants. NuScale's SMR technology is based on proven designs, leveraging existing light water nuclear reactor technology and conventional low-enriched uranium fuel supply. The NPM design is simple, integrating the reactor core, steam generators, and pressurizer in a single factory-built vessel, which improves safety and reduces costs. The technology is also scalable, allowing for configurations ranging from 1 to 12 modules, with typical scales of 12 module 924 MWe, 6 module 462 MWe, and 4 module 308 MWe versions. The company's SMR technology prioritizes safety, featuring an unlimited coping period during which NPMs can shut down and remain safe without operator intervention or additional cooling water. NuScale's NPMs can also start and operate without AC or DC power, providing reliable first responder power. Beyond NPM sales, NuScale offers a suite of services, including licensing support, testing, training, fuel supply services, and program management. These services are expected to generate consistent, recurring revenue throughout the project deployment phase and operating life of NPMs. NuScale has partnered with ENTRA1 as its commercialization and developer partner for NuScale SMRs. ENTRA1 will develop and construct new energy plants featuring NuScale SMRs, providing a one-stop shop integrated offering for deployment. The company is working on a project with Fluor in Romania and benefits from a global network of strategic investors and supply chain partners, including Fluor, Doosan Enerbility, and Samsung C&T Corporation. The U.S. Department of Energy, DOE, has granted NuScale 4 separate cost-share awards totaling over $578.3 million. NuScale's potential customers include domestic and international governments, utilities, state-owned enterprises, and technology and industrial companies seeking carbon-free, reliable energy. The industry is expected to see significant growth in electricity demand due to emerging markets, data centers, and electrification across the economy. This growth, combined with the retirement of older power capacity and the increasing share of intermittent renewables, will require more flexible assets to ensure supply security. Nuclear energy is seen as crucial in the transition to a low-carbon economy, with Bloomberg NEF suggesting that nuclear capacity needs to triple to reach net zero emissions by 2050. This will require extending the life of existing plants, accelerated deployment in various markets, and rapid development of small modular reactors, SMRs. A fully decarbonized global energy system by 2050 is estimated to come with a significant price tag, and investment in low-carbon energy needs to outpace fossil fuel investment. Nuclear energy, particularly SMRs, is viewed as an attractive option due to its reliability, competitive costs, and carbon-free emissions. The production of nuclear energy as baseload power is essential for maintaining carbon-free reliability in the electricity grid and is considered a national security imperative. Strong leadership in the green economy can support geopolitical interests, power economic growth, and enable global competitiveness. New clean baseload generation can provide reliable decarbonized energy for large technology companies to meet power needs for data centers and artificial intelligence while achieving sustainability objectives. SMRs are designed with scalable technology, utilizing module factory fabrication to achieve economies of series production and short construction times. They come in various primary technologies, including water-cooled reactors, fast neutron reactors, high-temperature gas reactors, and molten salt reactors. Light water reactors, like the NuScale Power Module (NPM), are considered to have the lowest technological risk and are the most developed from a commercial perspective. SMRs have inherent advantages over traditional large-scale nuclear and other carbon-free power generation. Their simplicity of design makes them easier to manufacture, construct, operate, and maintain, eliminating many nuclear components needed in large-scale plants. SMRs also have enhanced safety features such as smaller reactor cores and reduced potential for off-site release, which allows them to be located closer to population centers and industrial facilities. The robust design and multiple barriers preventing fission product release contribute to a low probability and consequence of radionuclide release. The economics of SMRs differ significantly from traditional nuclear facilities, which have high upfront capital costs and long construction times. SMRs are simpler, smaller, and largely factory-built, leading to shorter construction times and greater cost predictability. They are modular and scalable, allowing them to match customer needs while avoiding surplus capacity. This modularity reduces schedule risk and enables customers to right-size their power generation upon construction and scale up over time. SMRs also have a smaller footprint compared to traditional nuclear facilities. A typical nuclear facility requires a large area, whereas SMRs can be sited closer to the end user, reducing the need for transmission infrastructure and providing ancillary benefits such as process heat. The NuScale NPM is the product of extensive research and development with significant investment and regulatory approvals. The technology is protected by numerous patents globally. NuScale SMR-based power plants consist of multiple NPMs, each capable of producing a certain amount of electricity. The NPM design leverages existing light water nuclear reactor technology and fuel, eliminating the need for complex safety systems and other components found in conventional large-scale nuclear reactors. This results in a simplified system that improves safety and reduces capital and operational costs. The reactor operates using buoyancy-driven natural circulation, and the design keeps the water in the reactor system separate from the water inside the steam generator to prevent contamination. The NPM introduces key design innovations that make it the safest and most reliable provider of nuclear energy. Its design relies on well-established pressurized light water reactor technology, allowing it to be licensed within the existing regulatory framework and drawing on a vast body of established research and development. This proven foundation gives NuScale a significant advantage over other alternative and yet unproven nuclear technologies. The NPM incorporates all components for steam generation and heat exchange into a single integrated unit, eliminating large-bore interconnection piping that can be a potential source of failure and cause of construction complexity. Each NPM, including the containment vessel, can be entirely fabricated in a factory and shipped to the power plant site for assembly and installation, reducing fabrication costs, improving quality, and increasing schedule predictability. The reactor core of the NPM is cooled entirely by natural circulation of water, reducing capital and operational costs by eliminating reactor coolant pumps, pipes, and valves. The NPM can produce power continuously for approximately 20 months before refueling is required, and because of the multi-module design, each NPM can be refueled in a staggered manner, reducing total plant output for a short period. NuScale has designed an innovative control room that can control up to 12 NPMs with only 3 licensed operators, enabled by its proprietary highly integrated protection system. This platform provides a robust safety platform to monitor NPMs and help protect NuScale SMR-based power plants from potential cybersecurity attacks. The NPM's design innovations have allowed for several industry-first and best-in-class safety attributes. The NPMs are designed with fully passive safety systems and can remain safe in a cooling condition for an unlimited time following any extreme event that renders a power plant without external power. NuScale SMR-based power plants do not require any internal or external human or computer actions, AC or DC power, or additional water to cool the reactors. The NPM's design also supports a Site Boundary Emergency Planning Zone, EPZ, allowing NuScale SMR-based power plants to be sited closer to end users. The NRC has approved NuScale's methodology for calculating EPZ size, demonstrating that most NuScale SMR-based plant sites can be approved with a small EPZ. Additionally, the NuScale SMR-based power plant does not need costly emergency diesel generators to ensure the safety of the reactors in the event of a power loss. The NPM's design is resilient to man-made and natural events, including floods, earthquakes, tornadoes, and hurricanes, and can safely shut down following an electromagnetic pulse or geomagnetic disturbance. NuScale's design innovations and best-in-class safety case create several technology-enabled operational features that address critical industry needs with respect to grid resiliency and reliability. One of these features is the ability to operate without connection to the grid, allowing NuScale SMR-based plants to be sited in proximity to industries needing electricity and process heat. This also enables a NuScale SMR-based plant to replace a coal-fired power station located at the end of a single transmission line. The NuScale SMR-based power plant can act as a first responder to the restoration of the transmission grid, remaining at power and ready to immediately sell electricity to the grid when the grid is back online. Additionally, a NuScale SMR-based power plant has black start capability, allowing it to start up from cold conditions without external grid connections. A single NuScale power module, NPM, can supply all the house load electricity needs of the plant while also continuing to provide power to a local industrial customer or mission-critical facility without external grid connection via a microgrid connection. This island mode power feature provides highly reliable power, with the ability to provide a significant amount of power to mission-critical facilities with high availability over the life of the plant. NuScale's safety design has been validated through rigorous testing of critical components, and the company has constructed a test facility to demonstrate the operation of the entire nuclear steam supply system and safety systems. The NuScale testing programs have been audited by the U.S. Nuclear Regulatory Commission. NuScale's products and services include the sale of NuScale power modules and nuclear steam supply system equipment, as well as a diversified suite of services throughout the life of the power plant. These services include regulatory licensing support, startup testing and commissioning support, accredited training programs, and management of inspections, tests, analysis, and acceptance criteria process. NuScale also expects to provide design engineering management, operations and maintenance program management, procurement and spare parts management, nuclear fuel management, and outage planning and execution support. NuScale's innovative technology platform and intellectual property portfolio are significant competitive strengths. The company has a substantial number of patents issued and pending, which protect key aspects of its technology. Additionally, NuScale has a highly educated workforce with expertise in engineering and science, contributing to the company's ability to maintain its competitive advantage and expand its technology platform. Being the first SMR to receive a standard design approval, SDA, from the U.S. Nuclear Regulatory Commission, NRC, is another significant strength. This regulatory milestone provides customers with certainty about the plant design before committing significant capital to develop a nuclear facility. NuScale's SDA process was also notably faster than expected, demonstrating the company's efficiency in navigating regulatory procedures. The company's fully passive safety system design addresses historical concerns associated with traditional large-scale nuclear power plants. In the event of a total loss of power, a NuScale SMR-based power plant does not require any operator or computer actions, grid connection, or emergency backup power to remain safe indefinitely. This safety case enables NuScale to pursue a wide range of applications and commercial opportunities that traditional nuclear power plants cannot support. The company has also established a global network of strategic investors and supply chain partners, many of whom are blue-chip companies. This network is expected to play a critical role in the successful procurement of components and fuel supply, fabrication of components, and manufacturing of NuScale's power modules. Additionally, NuScale has received significant financial and regulatory support from the Department of Energy since its inception. NuScale's technology is cost-competitive both in the United States and globally, offering reliability, resiliency, and flexibility that customers and regulators value highly. The company's competitive cost, combined with its differentiated capabilities, gives it a significant competitive advantage over other technologies. The company's visionary management team, comprising experienced leaders and innovators, has extensive commercial and energy industry experience. The team's expertise in nuclear and engineering organizations such as the NRC, Department of Energy, and other prominent companies contributes to NuScale's ability to develop and commercialize its technology. In the competitive landscape, NuScale's SMR technology is currently the only NRC-approved SMR technology capable of meeting the growing demand for carbon-free baseload generation. The company's competitive strengths differentiate it from other power generation technologies, including traditional baseload, renewables, long-duration storage, and other nuclear reactors. NuScale has a strong pipeline of potential customers, including governments, utilities, and industrial companies, both in domestic and international markets. The company's technology can provide reliable electricity and heat energy to various facilities, such as chemical plants, direct air capture facilities, and water desalination plants, in an environmentally efficient manner. With its standard plant design and global partnerships, NuScale is well positioned to support clients in deploying site-specific designs and meeting their energy needs and carbon reduction goals. NuScale aims to grow its business by leveraging its competitive advantages in scalability, safety, reliability, and cost. The company believes that the market for its SMR-based power plants is wherever non-intermittent, reliable, carbon-free power is needed. Initially, NuScale is focused on replacing carbon-intensive coal-fired power plants and serving as an alternative to new-build gas-fired generation. In addition, the company is working with its partner ENTRA1 to position Entra1 energy plants with NuScale SMRs inside to various customers, including hyperscalers, technology companies, and industrial and microgrid customers. NuScale is also developing its international customer base with a significant effort to educate and market its technology to foreign governments and corporations. The company is well positioned to continue making technology advancements over time, including increasing power output, simplifying operations, reducing construction time, and reducing production costs. NuScale's research and development team is continuously working to improve its technology and meet customers' energy needs, creating opportunities for top-line growth and increasing margins. The company is exploring the development of innovative new products based on its core technology, such as a microreactor for niche end markets. This microreactor design is intended to supply power to remote, off-grid, and small communities, with potential applications in mining, universities, space power, military installations, and disaster relief. NuScale's supply chain is ready for deployment, and the company is mitigating manufacturing risks through strategic manufacturing trials of its key components. The company has completed manufacturing trials associated with its most critical component, the NuScale Power Module, NPM, and is progressing its NPM long lead material procurement. NuScale has strategically executed supply agreements with critical supply chain partners, allowing it to order key NPM components. The company has partnerships with leading global EPC firms such as Fluor, which collaborates with NuScale on plant design and provides engineering, project management, procurement, and construction services. NuScale has also received significant funding and support from the DOE to develop, certify, and commercialize its SMR technology. The company is aligned with ENTRA1 as its commercialization and developer partner for NuScale SMRs, offering a one-stop-shop energy solution to customers globally. NuScale's global network of strategic investors and supply chain partners is expected to play an integral role in bringing its technology to market around the world. The company has collaborations with academic institutions, including Oregon State University and other prominent universities, which have contributed to its research and development efforts. NuScale is also working with international organizations, such as the International Atomic Energy Agency, and regulators in various countries to facilitate the licensing of its SMR technology. For more on NuScale Power and other companies, follow Ascencore. Thanks for watching and have a nice day.